Mini Lesson 3B, Proofs. The majority of the first page is definitions. Let's read through them. Reflexive property, A equals A. Basically, just something equals itself. Substitution, if A equals B, then B can replace A in a given relation. Symmetric property, if A equals B, then B equals A. You can move stuff from one side of the equation to the other. Transitive property, if A equals B and B equals C, then A equals C. Midpoint, the point halfway between two endpoints. Segment bisector, a line that intersects the midpoint and divides a line into two equal segments. Angle bisector, divides an angle into two equal angles. Median, a segment bisector connecting a vertex to the midpoint of its opposite side. Altitude, a line segment that is perpendicular to the opposite side of a triangle. Vertical angles are equal to each other. Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Corresponding parts of a congruent triangle are congruent. CPCTC for short. The types of triangles are equilateral, isosceles, scalene, and then we have acute, right, and obtuse. Interior angles of a triangle equal 180 degrees. Triangle similarity with angle is AA. If triangles have two congruent corresponding angles, they are similar, but not necessarily congruent triangles. Here's more on the types of triangles in this diagram. Here's a picture of the altitude and the median. Notice they are not the same. We have different ways of showing that two triangles are congruent. We could use any of these right here. Side, side, side. So if you show that all three sides are equal on both triangles, that could show that both of those triangles are congruent. Same thing as if you show that both triangles have side, angle, side, angle, side, angle, 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 side. Or for right triangles, and you have the hypotenuse and the leg. Proving triangle congruence. This example has side, side, side. We're going to show it with that method. They give us the first step. AC is congruent to BD. So look at AC. This whole line is congruent to this whole line. That's a given. And then side DA is congruent to side CB. That's another given. Now to fill in this blank, we have two sides are equal and two sides are equal. We want to show if that third side is equal, which is just this line right here. It's the same line twice. So we could say that line AB is equal to itself. AB is congruent to AB. And when something is equal to itself, we call that the reflexive property. And from that, we can show that triangle ABC is congruent to triangle BAD. from side, side, side. Let's look at the next one. Our givens is that D is the midpoint of AC, and then we have ED is congruent to FD. So ED is congruent to FD. And then also angle EDA is congruent to angle FDC. So those are givens. Now, because this is the midpoint, we could say that line segment AD is equal to line segment DC. So we'll write line AD is congruent to line DC. And then our reasoning is because a midpoint divides a segment into two congruent segments. From there, we could conclude that triangle AED is congruent to triangle CFD using side, angle, side. We have a side, we have an angle, and then we have another side for each of those two triangles. The triangles we were proving they're congruent are these right here. Let's look at the next one. This one is going to be angle, side, angle. For this one, we're given that segment AE is parallel to segment FD. The segment AE is parallel to segment FD. And we show that by putting those little arrows on the sides. On the next part, we are given that segment BF is parallel to segment EC. So we have BF and then EC. To not confuse them with the previous ones, we'll draw two arrows on each side instead of just one. And then the third thing that we're given is that segment AC is congruent to segment BD. So on this one, we have two steps to fill in. For the first one, we could say that angle A is congruent to angle D because of the properties of parallel lines being cut by a transversal. And then we could prove that another set of angles are congruent, also by the parallel lines properties. So remember, if you have parallel lines and they're cut by transversal, the alternate interior angles are congruent. So we could say that these two angles are congruent. Angle ACE and angle DBF. And that's for the same reason as before. And then for our conclusions, so we'll say that triangle AEC is congruent to triangle DFB. So the whole triangles. And it's from angle, side, angle. Okay, let's look at the next one. This one we're going to find angle, angle, side. So our givens is side segment DE is congruent to side segment DF. And then we have angle A is congruent to angle C. Those are our givens. We could easily see that angle EDA is congruent to angle FDC because they are vertical angles, so they are congruent. And then we can conclude that triangle ADE is congruent to triangle CDF from angle, angle, side. We have two angles and then a side for both triangles so that they are congruent. Okay, let's look at the hypotenuse leg. This is just for right triangles. We're given three things. Line segment AD is perpendicular to line segment DB. Line segment BC is perpendicular to line segment CA. And then line segment AD is congruent to line segment CB. Whenever we have perpendicular line segments, they form right angles. So we can say that angle D is a right angle. And the reason is because perpendicular lines form right angles. And we could do the same thing for angle C. And then we'll just write that reason twice in these boxes. And then from here, we can state that triangle ADB and triangle BCA are right triangles because they contain a right angle. And then the reason gets the triangle contains a right angle. And then we could now say that line segment AB is equal to itself. So AB is congruent to AB, and you can say that's using the reflexive property. Therefore, we can write the conclusion that triangle ADB is congruent to triangle BCA from the hypotenuse leg property. Let's look at the last page on here. Interior angles of a quadrilateral is equal to 360 degrees. Identify the type of tetragon. Justify with reasons. All right, let's look at this one right here. We have some parallel sides and we have some angles here. And then we also know that these angles are going to be equal to each other because of their vertical angles. This is a parallelogram. It has vertical angles. And so you could say that angle, angle, side could be used to say that these are equal to each other. So that way we could say that this is equal to this. Parallelograms have parallel sides with opposite equal sides. All right, this one right here is a square. You could also say angle, angle, side could be used to say that these are equal triangles right here. And we get this 45 degrees right here because we know that these two are equal and they add up to 90 degrees. And then this next one, this tetragon is a kite. It has a pair of equal sides that are not parallel. Which, by the way, the whole entire thing is the kite. A, B, C, D. And then on the inside of this kite contains a different tetragon. It's a rhombus. So tetragon AECF is a rhombus. The adjacent sides are equal to each other. So these are equal and then these are equal. And then we have our quadrilateral family tree. We have quadrilaterals if they have two parallel sides, it's a trapezoid, or a parallelogram if it has two pairs of two parallel sides. If it has no parallel sides, it's a kite. Now for trapezoids, you could have an isosceles trapezoid if those two sides that are not parallel are equal to each other. For parallelograms, if each of the angles form right angles, that is a rectangle. If all four sides are equal but not the angles necessarily, it's a rhombus. And then if all sides are equal and all angles are equal, it's a square. Squares, all squares are rhombus, rectangles, and parallelograms, and quadrilaterals, but not all rectangles, rhombuses, and parallelograms and quadrilaterals are squares.